Yeah, what else are you thankful for? You thankful for your mom, your dad, your pet? Thankful for Newbold? Yeah, thanks for watching. So finishing 4.4 right now. We're actually going to jump to the notes for a second to remind you how to do this. Yeah, I don't remember teaching this last year, so this is good. Good refresher for me. So it's the factors of the constant divided by the factors of the leading coefficient, plus or minus. So the leading coefficient is a 1, and the constant is the number on the end, that's an 8. So list all possible rational zeros for f of x. So what we would do is we'd list all the factors of 8, and so that would be 1 and 8, and 2 and 4, right? So what are all the possible zeros? Well, plus or minus 1, 2, 4, and 8, all divided by the leading coefficient, which is the 1. So all divided by 1. So we didn't have to divide those by 2 this time, just by 1. And so that means all the possible ones are plus or minus. 1 divided by 1 is just 1. 2 divided by 1 is 2. 4 divided by 1 is 4. And 8 divided by 1 is 8. Way-o! So those are all the possible x equals. So on Canvas, I would probably have lots of different possibilities to choose from. You just click the ones that are right. In this case, there's 8 of them. Whoa! So let's take a look at our homework assignment now. So that's got a negative. So very similar. Very similar. Let's see. Determine all the possible rational roots. It's not all of them for sure, but it's all the possible that you'd have to check. So we have 3, 2, 1, 0. Good. So our leading coefficient is 1, that goes on the bottom, and negative 8, that goes on the top. So wow, what are all the possible factors of negative 8? Well, negative 8 could be a negative 1 times 8, or it could be a positive 1 times negative 8. We could also have a 2 times 4, 2 times 4, where the 2 is negative and the 4 is negative. So those are all the possible ones, and then you divide them all by 1. And they're all divisible by 1. So we get 8 of them, right? We get x equals, whoa, so many possible ones that we have to go through and check and see which ones actually work. To see which one actually works, we have to check all these. And maybe a couple of them just to get us going, and then use synthetic division. Yeah, so it could be negative. So here's our, so it could be negative 1, could be positive 1, could be negative 2 or positive 2, could be 8, negative 8, it could be 4, negative 4. Now the tricky part is that you have to divide all those by the leading coefficient, which is invisible 1. And so if you divide all those by 1, you just get the numbers back again. And so what if it was a 2? Then you'd have to divide them all by 2, which is the case in this one, right? And so we have a 2 and we have a 15. And so 15 possible factors are 1 and 15, and 3 and 5. Way-o! That was really difficult, wasn't it? Okay, don't worry. You can pause me right now and try number 17 now. So go ahead and list all the possible zeros. Doesn't mean they all work, but just list all the possible zeros, okay? So if we list all those possible zeros for h of x, good, using the rational root theorem. So we go ahead and use negative 12 with all of its factors, as well as 1, right? So what are all the factors of negative 12? Pause me, list them all. So we have 1 and 12. It could be positive or negative. We also have 2 and 6, 6 and 2. Could be positive and negative. We also have 3 and 4, and 4 and 3, right? And they could be positive or negative. So it could be 1 with a negative 12, or negative 1 with positive. Could be a negative 6, or negative 2 is the negative there, to times those together to get negative 12. And then it could be a negative 4 or a negative 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. all over 1. At least they're all over 1, okay? And because they're all over 1, we don't have to worry about dividing them by 2 or anything. That's good at least. Okay, so all the possible are, let's take a look, plus or minus. We have 1, 3, no. We have 1, 2, 3, 4, 6, and 12. All over 1. Determine which of these possible zeros are actually zeros by using the factor theorem or the remainder theorem with your calculator. So what that means is to plug each one of those into the equation and see which one gives you 0. And so you probably need like 2 of them, because then you can do synthetic division and then use the next one to do synthetic division. But this is just x to the 3rd power, so we probably only need 1 of them to work. Yeah, which one do you think is going to work? Well, we go ahead and do to the 3rd power plus 2x squared minus 6 times x minus 12. And so I just got that from this equation here. Well. So I just went ahead and brought each of those down. Yeah. So I just brought those down, and I'm going to just try plugging in each of these numbers and see which one works. I mean, 1's pretty fast, right? We just need 1 of them to work. So 1 to the 3rd power is 1. 1 squared is 1 times 2. Minus 6 minus 12. That's not going to equal 0. So maybe 1 is not going to work. Maybe 1's not going to work. Let's try maybe 2. Do you think 2 will work? Now you can use your calculator, which I'll show you in a second, a shortcut. But let's try 2. Maybe 2 will work. So if we plug in a 2, we get 2. Plug in 2, we get 2 to the 3rd power is 8. 2 squared, 2 times 2 is 4 times 2 is 8. Minus 6 times 2 is negative 12, and minus 12. Well, that's getting closer, but we're not quite there. What if they're negative? Make them negative. So this becomes a negative 8 plus negative 2 squared is 4, and 4 times 2 is 8. What if we plug a negative 2 in? Whoa, negative 2 times negative 6 is a positive 12. We found it. Yeah, those equal 0. We got a remainder of 0, right? Using the factor theorem or remainder theorem. And so factor theorem is at 0. So that means that negative 2 worked. So x equals negative 2 worked because we got a remainder of 0. And so then let's reverse engineer that. That would be, oh no, we can just use that now for synthetic division. Synthetic division. So we bring down our equation, and we have x to the 3rd power plus 2x squared minus 6x minus 12. Now remember, synthetic division, you guys, just uses the numbers, the invisible 1. And so we're going to take negative 2, which is already solved for x, and we're going to do an upside down house. Upside down house. And so we're going to bring down our 1, bring down our x squared term, which is 2, bring down our x term, which is 6, and 12. And we should get 0, right? We should get 0, remainder 0. But this will give us the next part of our equation, then we can just factor that and get the other zeros. So we bring down a 1, and so here we go. Negative 2, synthetic division, remember? Negative 2 times 1 is negative 2. That gives us a 0. And then negative 2 times 0 is just 0. So we add those together and we get a negative 6. Combine them, combine them. Combine a negative number with a 0. And then what's negative 2 times negative 6? That's positive 12. Now we combine them. What's negative 12 with a positive 12? It's 0, which we knew already. But now we have our factored answer, because we're trying to factor it all and get all the zeros, get all the roots. And so then this 1, is it 1 power more or 1 power less? Can you remember? 1x to the original is 3, that's the degree. Go 1 power less. So what's less than 3? Less than 3 is a 2. So 2 is 1 power less. So use the 2, use the 2. So that's x to the squared power. And then plus 0x. and then minus 6. Whoa. Okay, so then we get x squared minus 6, because the 0 goes away. 0 times x is just 0. And so that's our other factor. Our other factor with x equals, so that was a negative 2, which is actually a positive 2. So those are all our factors. And they want you to find the exact values of all the zeros. Okay. Well, tricky now. So we do have, set that equal to 0 again. That's just negative 2, which is one of our zeros that we found using the factor theorem. So now we just take this one, x squared minus 6. We set equal to 0. We add 6 to the other side. And then we have x squared equals a positive 6. And then do you remember what we do? To get rid of the power 2. We square root both sides. So we get x equals plus or minus radical 6. So the answer to number 17 is x equals negative 2 and a positive radical 6 and a negative radical 6. Our zeros. So it's interesting that our zeros does incorporate negative 2, but out of all these numbers, it was just a negative 2 that worked, right? Just the negative 2 and everything else, no? That's crazy. So that's interesting, right? So I'm going to pause and make sure I did that right. Yeah, we got it right. Excellent. So now let's jump over. You try number 18 next. Try number 18. And try number 19. Try them both on your own. On number 19, if you're still concerned about finding all the zeros and plugging into the equation, I'll show you with the calculator this time how you can do a shortcut there, okay? So we'll go to number 19, where there's lots of, well, there's not too many to check actually, but I'll still show you. You can use your regular calculator, 1050, doing this. Okay, so we have, for number 19, we have, let me see, does 18 have a lot more? 18, not really, just 1, 4, 2, and negative 2. That's not bad. And same with number 19, not too bad. So let's just go and show it to you. So what you have to do first is find all the possible zeros first, right? So find all possible zeros to narrow it down, and then we'll find the actual ones that work. So remember, we take 10 and we list all the factors. So 10 times 1, 2 times 5, 5 times 2, 1 times 10, and then divide them all by 1. Divide them all by 1. So we get x equals plus or minus, let's see here, so plus or minus, we have a 1, and a 2, and a 5, and a 10. So you can actually use your calculator and you can actually make x whatever you want. So right now my x is a 1, which is already ready to go, right? Positive 1. So if my x is already equal to 1, I can just type my equation in and it'll tell me if it's the remainder of 0 or not. Really? Really? Ready? Here we go. So we're going to type in there. We're going to type this into our calculator. Type it into our calculator. Or you can type them all in with parentheses, but this is more fun. So we're going to do x to the third power minus 5 x squared minus 2 times x. You don't really need the parentheses, but I just want to make sure the calculator does it right. Again, x equals 1 right now. Well, 1 didn't work. 1 did not work. What about negative 1? Because positive 1 did not work. Remember, you have to get a remainder of 0. So then we go ahead and store negative 1. Where's the store button? It's right here next to the 1. Can you see it? Right there. Do you see it's red right now? See the STO arrow? So negative 1 store into x. And now whenever I type an x in, it's going to give me negative 1. So now if I push second, enter, second, enter, second, enter, it brings up the equation. And now what does negative 1 give us? A 6. That's not a remainder of 0, so that doesn't work either. So now we try a 2 next. You can graph it as well, and you can graph it and go to the second table. You can graph it and see where all the zeros are. That's another way to do it. But I like this way. This way's kind of fun. So now I want to store, let's see, let's try 2 next. So let's go and store, actually let's go with 5. I feel like 5 might be a winner. So we're going to store 5 into x. So now x equals a 5. And then we go up to the last thing that we did, which is this guy, and push enter. Or you can push second enter, second enter. Well, it worked! It worked! So we got x equals a 5. So 5 is one of our x-intercepts. Way-o! So a positive 5, right? A positive 5 works. So now that we know a positive 5 works, we can go ahead and do synthetic division. So 5 upside down house. Now remember, your calculator, it can find all the roots if you just keep going through all of them. No, it won't, because it only maybe gives you 1 or 2 of them. And you have to do division, synthetic division, long division to find the other roots. They might be imaginary. They might be radicals. So yep, we do have to do this next. So bring down each of those leading coefficients, the 1. Remember how to do synthetic division? Synthetic division. So we bring down the 1, multiply, combine it, multiply, combine it, multiply, combine it. So 5 times 1 is a 5. 5 with the negative 5 is 0. 5 times 0 is just 0. So the negative 2 plus 0 is just negative 2. And then 5 times negative 2 is negative 10. Way-o! So now we get, right? So now we get our equation. Remember that it's 1 power less. 1 power less is what we're going to use. Yeah, 1 power less. So that's going to be 1x to the squared plus 0x minus 2. So then we get our other equation, which is the 0 goes away. So just x squared minus 2. So we have one of our factors is 5. And the other one is x squared minus 2 set equal to 0. Add 2 to the other side. So we get x squared equals 2. And then we square root both sides. Way-o, plus or minus. So x equals plus or minus radical 2. So we get x equals a plus. So x equals a radical 2. And x equals a negative radical 2. Way-o. And so then we go ahead on Canvas and check those boxes for the roots, right? For the zeros. For the zeros. So you try 18, you try 20, you try 21 on your own. You got this. Using what you know about zeros and behavior, do a rough graph. Yeah, find all the zeros. Remember, find all the zeros. Nice. Find all the zeros for this one that we just did. So 20 and 21 are kind of together. So they help you find the roots, and then synthetic division. You might have to do factor by grouping, honestly. Factor by grouping for number 20. Before, we just we were able to just set it equal to 0. And but you might have to factor by grouping maybe. Because x to the 4th power is bigger than the 3rd power. So probably have to do factor by grouping. Or you might have to do synthetic division again. Right? Do synthetic division twice. So thanks for watching. Thanks for watching. Let's see. Odds, Newbold. There's no odds. Oh, a circle graphed on a standard xy coordinate plane has a center at -2, 3. -2, up 3. So -2, 3. And it passes through the points -3, -1, which is down here. Interesting. -3, -1. So if it's a circle, that means that distance is going to be the what? If it's a circle, that distance is the radius. Distance is the radius. So if the diameter AB, right? AB, what's A and B? Where's B? If the diameter AB were created, what would be the coordinates needed to be for B? Oh, so they want you to find this coordinate way up here. They want you to find B. Okay, well, this is again -3, -1. Left 3 down 1. This is left 2 up 3 is the center. And so we want to find that distance, okay? So what's that distance? Let's use the distance. Use the distance formula. Maybe you could even count it off. No, let's use the distance formula. I think you could count it off. Don't you think you could count it off? So we would go what? We would go down. 1, 2, 3, 4. So we go down 4. And then we go over 1. Huh? So go back 1. So back 1. So negative 1. So down 4, back 1. So that means we should probably go what? We should probably go from this point, negative 2, 3. Instead of going back 1 on the x values, we should probably go over 1, right? Go over 1. And then go up. 1, 2, 3, 4. Yeah. So over 1 would take you to negative 1. And then up 4 would be from 3. We would go 4, 5, 6, 7. Yeah. So negative 1, 7. Negative 1, 7. We got it. Didn't even have to use the distance formula. Right? Didn't even have to use the distance formula. We just counted it out. That's amazing. Just counted it out. So thanks for watching and ask questions in class. You got this. I believe in you. Thanks for watching. Get ready for our test next. Unit 4 test. Let's go. Thanks for watching. See you soon on the review. Thanks for watching.